I'm in my AWS console. To start an EC2 cluster, you first need to go into Elastic Container Service. So search Elastic Container Service. You can go it from here like this. Alternatively, you can go to Services, and under Compute, you can find Elastic Container Service. So click that. So this will take you to the Elastic Container Service section of AWS console. Go to the clusters, because we are going to create a cluster. As of now, I don't have any clusters. So click Create Cluster button. So depending on the region that you are executing it, sometimes you may find a different set of boxes. But what we are going to select here is EC2 Windows plus Networking Cluster. So select that and go to Next Step. Give your cluster a name. So in this case, I'm going to say my Contoso cluster. So far so good. You need to select on-demand instances. You cannot select spot instances because the account the instructor has given you does not have permission to start spot instances. So select on-demand instances. You can only run certain instance types. The types of instance that are allowed to start are given in your lab document. So in this case, I'm going to select the allowed instance type for me, which is T2 large instance. So it may be different for you, and it is given in your lab document. The number of instances that I want to run is 1. You can of course increase this one later after creating the cluster. The storage is 50. I'm going to remote login into my cluster for debugging purposes. So therefore, I'm going to select my secret key that I created. In production environment, you don't define a secret key, so no one can log in into them. So for networking, select the VPC. The VPC that got created as part of the CloudFormation that got executed is this Contoso VPC. So select that. You have two subnets, public subnets, pub1 and pub2. Usually the clusters you run in private subnets, but this is a lab environment and we don't want to spend time creating these NAT gateways and making the connections. So in this case, I'm going to put them into public subnets. The security group that allows traffic into this is already created for you, and it starts with the ECS instance dash security group. So this the ending ID may be different in your account, but in my case it's 390D. So but what you need to select is this ECS instance dash security group, SG security group. You don't need to create an IAM role. This IAM role that you need to select is called ECS instance role dash some number. So this is the one that you need to select. This security group allows certain traffic into your EC2 instance that the cluster will start, and also we have configured it in a way that it allows traffic from a security group called load balancer security group. So later part of in your lab, when we configure a website to run, that load balancer will be able to send traffic to this EC2 instance, and that's why we selected this security group instead of creating a new one. You can go and inspect if you like. The IAM role has permission to invoke certain commands, including Amazon ECR and ECS APIs. So this allows the Amazon EC2 instance that the cluster starts to download the images from Amazon ECR. So everything looks good. Click Create. So this will start a CloudFormation template that will provision the resources the cluster wants. So as of now, it's been executed. It will take some time to finish this cluster creation. So meanwhile, you can go to services and explore what kind of resources this CloudFormation is going to provision. So if you go to CloudFormation, you can find that there is a CloudFormation template that gets executed. It's called EC2 container service dash my contoso cluster. And if you exploit, you can find that it's provisioning certain resources like auto scaling group and launch configurations. So give it some time. Cluster creation CloudFormation template has completed successfully. If you go into the resources, you can find what resources it has provisioned. So if I go into my EC2 section of the console, so as of now I have one running instance. If you keep refreshing, at some point in time you will find that the cluster will start at one instance. So you can find this instance is started by the cluster. It's called ECS instance EC2 container service my contoso cluster. So this is started by that CloudFormation template execution. If you go and explore the tags, you can find the CloudFormation template that it created. So this instance will start and it will take some time for it to boot up. Once the initial state becomes green, it's going to execute some commands to register this instance against the cluster. So if you go into your Elastic Container Service, as of now there's 0 registered containers. At some point container instance or container hosts, at some point in time, once that instance boots up, it will register against this cluster and you will find number 1 here. You can find that EC2 instance has started and everything is good. So at some point in time, it will register itself against the cluster. I'm in my cluster section. As of now, it's still container instance is 0. So if I keep refreshing, you can find that it turns into 1. So now this cluster is ready. It has one container host that is registered against that. ECS has a concept called Fargate, which is a managed cluster, which automatically scales. But in these lab environments, we are going to explore EC2 based cluster where you manage the environments or the EC2 instances. If you go into my contoso cluster and select ECS instances, you can find the instances registered against this cluster. You can navigate to the EC2 instance from here, especially if you have a lot of instances, it's easy to navigate. It gives you things like the number of tasks that is running, which we will discuss shortly, how much CPU this EC2 instance provides for the cluster, the memory available or the amount of memory this provides for the cluster, the ECS agent installed and the Docker version running. In the subsequent lab, we are going to create a task and run that task, which will start some containers in this cluster. So let's move to the next lab.